Hello children, welcome to AIMS India's online classes. In today's video, from mathematics subject, exponents and powers topic we are going to continue. So today children, we are going to learn about zero and negative integral exponents. About zero exponents and about negative integral exponents we are going to learn. Suppose for any non-zero rational number a, here we have to assume, we have to take a value a which is a non-zero rational number, which can be any non-zero rational number, and with that a, this a to the power of 5 by a to the power of 5, if we have a rational number like this, a to the power of 5 by a to the power of 5, that equals to, because whenever we have exponent in the denominator, we can take it to the numerator and we can write it as a power minus 5. So this a power 5 by a to the power of 5 can be written as a to the power of 5 into, in denominator a to the power of 5, if we take to the numerator, it will become a to the power of minus 5. Base will be the same, but the sign of the exponent will change. And whenever we are multiplying the two bases, same bases, having different powers, what we can do means, we can write them under the same base and we can add the powers. So it will become a power 5 minus 5, which is equal to a power 0. So a power 5 by a power 5 can be written as a power 5 minus 5, which can be written as a power 0. But according to normal mathematical calculations, whenever we have same value in the numerator part and denominator part, both will get cancelled and the answer will be 1. So, but we know that a power 5 by a power 5, as we have same value in the numerator and denominator, both will get cancelled and we will get the answer 1. According to rules of exponents, we are getting a power 0 in first case. According to normal mathematical rules, we are getting 1 in the second case, which are the values of same terms, a power 5 by a power 5. So indirectly, we can tell from first case and second case, a power 0 equals to 1. A power 0 equals to 1. Means any base, if it has the exponent 0, then its value will be 1. Here what is a? A should be any non-zero rational number. So for any non-zero rational number like a power 0 will always be equal to 1. Will always be equal to 1. Okay. So next, suppose if we have question like this, a to the power of 3 by a to the power of 9. A to the power of 3 by a to the power of 9. So this in denominator part, we have a to the power of 9. If we take it to numerator part, what does it will become? What does it will become? A cube into a to the power of minus 9. Like that we can write. But here bases are same. In a cube and a power minus 9, the bases are same. So we can combine them into one base. We can combine them into one base a, and we can add the exponents. 3 minus 9 we can write directly. So 3 minus 9 results in minus 6. So a power minus 6 is the value of a to the power of 3 by a to the power of 9. In another way, a to the power of 3 by a to the power of 9 can also be written as, if the numerator comes to the denominator, so then, so 1 by a to the power of 9 into a to the power of minus 9. Now the numerator is coming to the denominator, so it will become a power minus 3. Again, in denominator part, we are having the same base. We can write the base, common base, and we can add the exponents. So we can write it as a power 9 minus 3, which is equal to 1 by a power 6. So in one way, we can write it as a power minus 6. We can also write it as 1 by a power 6. So what it means, a power minus 6 is same as 1 by a power 6. Means whenever we have negative exponent to any base, it can be written as 1 by a power positive exponent. Whenever we have a negative exponent for a non-zero rational number as base, then it can be written as 1 by same base. For the same base, we have to change the sign. So a power minus 6 can be written as 1 by a power 6. So in this way, we can write 0 exponents and we can write negative integral exponents. So 0 exponents means any non-zero rational number, rise it to the power of 0, or any non-zero rational number, if it has 0 as exponent, its value will always be equal to 1. And second thing, any non-zero rational number, if it has negative integer can be as exponent, it can be written as 1 by positive exponent to the same base. 1 by positive exponent to the same base. So these two things, these two rules we have to keep in mind, children, while solving the problems. So next. So therefore, let a by b be any non-zero rational number and n be any positive integer. So a by b whole power 0 is equal to 1. Always will be equal to 1. So any base to the power of 0 always equals to 1. Suppose this same a by b rational number, if it has negative exponent, it can be written as 1 by same base, but exponent will become positive. 1 by a by b whole power n. Like that we can write. But in the denominator, again we are having denominator. So this also can be written as, this in denominator, whatever denominator is there, it will go to the numerator part. So it will become its reciprocal. It can also be written as b by a whole power n. b by a whole power n. So whenever we have negative exponent, in one way, we can write it as 1 by positive exponent to the same base. Otherwise, if we have a rational number in the base, we can write the reciprocal of the rational number and we can change the sign of the exponent. In that way also we can write. These two are the ways of representation of negative exponent values. Next children. So, loss of exponents for all integral powers. Loss of exponents for all integral powers. So, let a by b and c by d be any two non-zero rational numbers, and let m and n be any integers, either positive or negative, any integers. So then a by b whole power m by into a by b whole power n means for the base we are having power m, and for the same base we are having power n. We are multiplying the both. Then we can combine the bases into one base and we can take the sum of the exponents. So if we have different exponents for the same bases and we are doing product of them, then instead of 2 times we can write the base for 1 time and we can do the sum of the powers and we can keep it as common exponent. So this is the first law, children, regarding laws of exponents. This is the first law. So in this way, if we have 9 by 11 whole to the power of minus 4 into 9 by 11 whole to the power of minus 5, here the bases are same, exponents are different. We can write the base for one time and we can take the sum of the exponents. What are the exponents? Minus 4, minus 5. So minus 4 plus minus 5. Plus into minus, minus. Minus 4 minus 5, which is equal to minus 9. Which is equal to minus 9. Next, in that way we can simplify. Here, 4 by 5 whole to the power of minus 7 into 4 by 5 whole to the power of 5. We are having the same base, different exponents. We are doing the product. So we can write the base for one time and we can take the sum of the exponents. What is the base here? 4 by 5 whole to the power of minus 7 plus 5, which is equal to minus 2. But here the exponent is negative and in base we have rational number. So what we can do? We can write its reciprocal and we can change the sign of the exponent. 4 by 5 whole power minus 2 will become 5 by 4 whole square. Base will become its reciprocal, exponent will become positive. Like that, children. So here in the first question also, 9 by 11 whole power minus 9 can be written as 11 by 9 whole power plus 9. Next, children. Minus 2 by 7 whole power minus 3, minus 2 by 7 whole power 6. Bases are same, exponents are different. We are doing the product. We can write the base for one time. We can take the sum of exponents. Minus 2 by 7, 6 minus 3 equals to plus 3. So in this way, using first law, we can simplify the problems, children. Next one, second law. Second law, a by b whole power m whole power n. If the same base is raised to one power, again raised to another power, then we can do the product of two powers for the same base. That is the second law, children. A by b whole power m whole power n. We can write it as a by b whole power mn. We can do the product of the two powers. And we can write it as single power. The product will be written as single power. A by b whole to the power of mn. So this is the second law, children. So based on this law, suppose we have a question like this. 3 by 5 whole power minus 3 whole cube. For the same base, we are having two powers. So what we can do? We can take the product of, we can do the product of two powers. 3 by 5 whole to the power of minus 3 into 3, which is equal to minus 9. 3 by 5 whole to the power of minus 9. If you want to write in terms of positive power, we can write the reciprocal of 3 by 5, which is equal to 5 by 3 whole power plus 9. Like that also we can write. Or another example, minus 5 by 13 whole power minus 4 whole power minus 5. Here the base is minus 5 by 13. For the same base, we have the powers. One power is minus 4, another power is minus 5. So what we can do? We can do the product of two powers. Minus 5 by 13 whole power minus 4 into minus 5. Minus into minus plus 5 4 times 20. 5 4 times 20. So here this minus 5 by 13 can be written as minus 1 into 5 by 13 whole power 20. this minus can be separated into minus 1 into 5 by 13 whole power 20, but minus 1 to the power of 20, because if we separate it, its meaning is minus 1 to the power of 20 into 5 by 13 whole power 20. We can separate into two terms, but negative integer minus 1 to rise it to even number always will be positive, because minus 1 to the power of even integer always equals to 1. So that's why this minus whole to the power of 20 will become positive. So no need to keep minus. Minus 5 by 13 whole power 20 can be written as 5 by 13 whole power 20. Why? Because minus to the power of 20 is always positive. So that is the answer. Next children, that is second law. Next children, next law 3, third law of exponents. A by b whole to the power of m into c by d whole to the power of m. If you observe the product and terms, children, here the bases are different and powers are same. Exponents are same. So if the bases are different and exponents are same, what we can do means we can do the product of bases and we can write common power. So what are the bases here? One base is a by b, another base is c by d. We can do their product, a by b into c by d whole power. Instead of 2 times, one common power we will write, whole power m. Like that we can write when we have same power for different bases. Suppose, for example, we have a question like this: 7 cube into 3 by 14 whole cube. For first term we have cube, for this second one also we have cube. 2 times we are having the same power but different bases are there. We can do the product of bases, 7 into 3 by 14 whole cube. Instead of 2 times, we will write only 1 time, 7 2 times 14. So after cancellation, 7 2 times 14, after cancellation, we will be having 3 by 2 whole cube, which means 3 cube by 2 cube. 3 cube value 27, 2 cube value 8. So 27 by 8 is the correct answer. 27 by 8 is the correct answer. Next. Suppose we have one more example. 7 by 11 whole power minus 6 into minus 11 by 7 whole power minus 6. Here bases are different but powers are same. We can take the product of bases. 7 by 11 into minus 11 by 7 whole to the power of common power minus 6 we will write. So after cancellation, 7 7 gets cancelled, 11 11 gets cancelled, only minus will remain. There is no number. We can write it as minus 1 whole power minus 6. But in exponent we have minus 6. We want to make it positive. So what we can do? 1 by minus 1 whole power 6. Like that we can write. But minus 1 whole power 6 means minus 1 is having even integer as exponent, whose value will become positive 1 plus 1. So 1 by 1, which is equal to 1. In this way, with the help of two laws, we can simplify this problem. Next children, law 4, fourth law children, fourth law. So a by b whole power m divided by a by b whole power n means we are having the same base but different exponents are there. If we divide such terms, then they can be combined as, instead of same base, we can write base for one time. As we are dividing both the bases, common bases having different powers, what we have to do means, for the same base, for the common base, we have to write difference of exponents as the common exponent. So a by b whole power m divided by a by b whole power n can be written as a by b whole power m minus n. So from the exponent which is in the numerator, we have to minus the exponent which is in the denominator, means m minus n. So for example, if you have minus 3 by 8 whole power 11 divided by minus 3 by 8 whole power minus 5, here the bases are same, exponents are different, same base. One time we will write minus 3 by 8 we will write, and the exponents we will do minus. So 11 minus of minus 5, because in numerator we have exponent 11, in denominator we have minus 5. So 11 minus of minus 5 we have to write. Minus into minus plus, it will become 11 plus 5, which is equal to 16. So this is fourth law, children. This is fourth law. Next, law 5, fifth law. So for any non-zero rational number a by b and positive integer n, a by b whole power minus n can be written as b by a whole power n. So already we have discussed this, children. Let's prove this, children. So a by b whole power minus n, because here in exponent we have negative term, negative exponent, can be written as 1 by a by b whole power n. If we write 1 by, exponent will become positive. 1 by, again a by b whole power n can be written as a power n by b power n. But in denominator, again denominator will go to the numerator. So b power n by a power n, which is equal to b by a whole power n. Or whenever we have a by b whole power minus n, whenever we have negative exponent, we can write the reciprocal of the base and we can make the exponent positive. Or if you have only a power minus n, then you can write it as 1 by a power n. You can keep 1 by and you can write a power n. Like that, children. So for example, minus 5 whole to the power of minus 1, minus 5 whole to the power of minus 1, if you want to simplify. So this minus 5 can be written as minus 5 by 1 whole power minus 1. We have to write its reciprocal, 1 by minus 5 whole power 1. Whole power 1 means its value is equal to 1 by minus 5. But minus always to be kept for the numerator. So minus 1 by 5 is the answer. So or else, another example, 2 by 3 whole power minus 3 can be written as, because we have negative exponent here, we have to write its reciprocal. 2 by 3 converts into 3 by 2, minus 3 changes into plus 3. 3 cube by 2 cube. 3 cube value 27, 2 cube value 8. So in this way, we have 5 laws, children. Regarding the exponents, we have 5 laws. So first, zero exponent means a power 0 equals to 1. So any base raised to the power of 0 is 1, but a should be any non-zero rational number. And whenever we have negative exponent, it can be written as 1 by positive exponent to the same base. Or first law, a by b whole power m, a by b whole power n, same base. If you have different powers, we can write base for one time and we can write the sum of the exponents as the common exponent. If we have two powers for the same base, we can take the product as the common power. If we have different bases for common exponent, we can take the product of different bases as the base and we can keep the power one time. If we divide same bases with the different powers, then we can take the base for one time and we can subtract the exponents. So if we have negative exponent for a rational number, we can write its reciprocal and we can take the positive exponent. Okay, children. These are the laws of exponents, children. Remaining problems we will discuss in our next video. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website, children, www.aimstoday.in, for information regarding online classes, quizzes, worksheets, activities, English class and coding skills. Thank you, children. Have a good day.